Hi everyone, this is a new episode of Entry Live. Welcome everyone join us today. And so our topic today is Entry multi-cluster gateway. And let's welcome Lan and Jiajing to introduce themselves first.
Hey, hello everyone. Good morning, good afternoon, good evening. And I'm Roland, and I'm working on entry as for now I'm entry manager, and most of my time I'm working on the multi-cluster. So today I will show you the overview of multi-cluster feature on the entry and also the new feature entry multi-cluster gateway. Yeah, thanks.
And Also, for the audience, so if you are the first time joining us today, feel free to log into your YouTube account so that you can leave your questions or any comments in the comment part, and we can see that in a real time and answer your question as well. So, and also if you like, uh, so if you like this kind of content and if you are interested in Kubernetes, Antrea, VMware's product or networking, feel free to check out our channel. And if you like those contents, please consider like and subscribe the channel. Okay, so we have a plenty of contents today, so let's just jump into it.
Mm, okay. So, hello everyone. And I think for entry multi-cluster, last time actually there was a session about the multi-cluster. Before we jump to today's new feature, I still like to maybe give a quick overview of our multi-cluster architecture, so you can have some background about this, to understand the following content. You know that when we talk about entry multi-cluster, the multi-cluster means that there are a group of clusters, and in entry multi-cluster, we have a class set, which means a group of Kubernetes cluster, and they will work together to to share those resource and share service, so they can uh, uh, access those services across the cluster in a cluster set. If you look at this picture, this diagram, we actually have actually three clusters. One is our leader cluster, and the two are member cluster. Here is the role. So in a class set, usually there are at least one leader cluster. For now, we only support one leader cluster, and I think at least two member clusters to to uh, to I think to be a class set in our entry. And so this is the basic topology of entry multi-cluster. And of course, you can have multiple multi-cluster, multiple member cluster, but we only support one leader cluster here. And the major multi-cluster feature in our entry or in upstream, we define that the purpose of the class set is to share the service and those resources in different clusters. So, as I just mentioned, that the class set is the group of our member cluster and the leader cluster, and based on this basic topology, we will share different resources by the leader. A member cluster will share its resource with a different CRD, and the leader will have those shared resource and share those information to other member clusters. So all the member clusters can see those shared information through the leader cluster, and this is our basic background. And you know that if you want to use the multi-class feature, we have to install our multi-class controller. And both leader and member requires different controllers and play different roles in member cluster. The core role is to as a exporter because export and import because it will have it have to tell the other members what kind of information I like to share to others, and I also the member cluster also like to import this resource from other member clusters. And here is our the core feature in our Mad cluster. The purpose is to share the service and between different member clusters. I think we have those introduction before, so probably I will give a simple introduction about this. Uh, you know that our multi-class controller will export the service. Export the service export is a concept which, if you want to export the service to other member cluster to share the service and to allow other member cluster to access this service, then you can create a service export to say that hey the service full under the for example the service full under the NS namespace, you like to share this service to other member cluster, then you can create a service export including the name and namespace to tell the leader that hey I would like to share the service to others. Then other member clusters will look at or watch this kind of shared information on the common area, then import the necessary service. Uh, we will actually watch the resource import. It's actually, you can consider that's a wrapper of a service. We have different resource can be shared. For now, the core part is a service. So once we watch this information, we will create the service, corresponding service endpoint. I like to highlight that in our importer, the service is actually, we call it multi-class service. It's including the service information like the IP, sorry, not the IP, usually the port definition, the label selector, etc. And like this, and also endpoints. This endpoint in our default mode, we will use cluster IP from other member cluster service. I think if you have any Kubernetes background, you may know that general service. So if you create a service on one local cluster, you may have the endpoint, but the endpoint is policy IP, right? But here in our multi-class service, we will have an endpoint including the cluster IP of remote clusters service, or we say exported service, so cluster IP. Yeah, maybe it's. I believe Jiajing will demo and show you that it might be easier to understand that from user perspective. And yeah, that's the major background. And since 1.7 we have a multi-class gateway. I think if you are early use of multi-class and multi-class feature, you may notice that at the very beginning we are using the pod IP as endpoint, as a class endpoint, and it requires underlying network to support this, so they can use the multi-cloud service. Because you have the underlying network have to guarantee that we have the pod-to-pod IP access. But for now, since we have the cluster IP as the endpoint, the cluster IP is more stable, and usually the cluster IP cannot be accessed by outside world, or we say other member clusters. It cannot be accessed directly. So we introduced the gateway feature, and from 1.7. The gateway here, the concepts actually, why we say gateway, because in a multi-class environment, we would see that sometimes not all the nodes can be accessed by other clusters. So usually we would like to pick one node from the node list as the gateway. The gateway means that, or the requirement is that all the gateway from different member clusters have to access each other, which means the network connection is accessed. But for other regular nodes, for example, here the node A2, you don't have the access to other clusters nodes, because all the traffic or we see the multi-cluster or cluster cross-cluster traffic will be forwarded by the gateway instead of send out directly. In a typical scenario, for example, here in our diagram, we would show that how a pod access service, multi-class service. You know that which I mentioned before, that a multi-class service endpoint is a cluster IP of other member cluster service. For example, we have both class B and the class C. We have our service. Let's say here we have a traffic work. Let's say that we have Nginx. Nginx service, both class C and the class B have this Nginx service, and they also have each cluster have one pod behind it to run the workload and to provide the service. And so once you export the service from class C and class B, class A will get this kind of information, and there will be a local service named entry MC and jigs, like this one. See, here is actually the service we mentioned. It's the multi-cluster service entry in entry case. Then, as you can see, it will have endpoints like the cluster IP, these two. Then sorry, this it's this is the class IP, or maybe we can take a look at this one a little detail. So if pod A want to access this IP, this service, it means it like to access multi-class service. Once the pod A, let's go back to the diagram. Once the pod A trying to access the entry MC Nginx, it actually will access the class IP, the local class IP of this class A, right? But the background endpoint is actually the class IP of other clusters service. So when it's do the first DNet, it's actually translate the class IP of the local cluster IP to the remote service class IP. So it will be known by the entry OS to understand that, hey, this one should be routed or forwarded to the gateway, because it's remote traffic, not our local traffic. So it will be forwarded to our gateway. Once the traffic hits the gateway, actually the gateway will forward this to remote. But it's which cluster it will choose. It actually depends on the DNet step. In the DNet step, it will choose one cluster IP. This cluster IP will be decided by our flow rules, and it will know which cluster it belongs to. So, for example, here we choose the cluster C as our destination. So before it goes out of this cluster A, it will actually do the SNet, which means the source IP will translate it to our gateway's IP, so the outside world can know and know how make the traffic back to the class A, right? Because the local pod IP is unknown to other clusters. So once the traffic goes to our destination cluster here, it will first go to the gateway node through the tunnel. Here we have a Geneva tunnel by default, and since the traffic is actually is requested to the cluster IP of class C, and it still need to translate it to the real pod IP. You know, this scenario is actually almost like the same way you access the local service, right? Once you access local service, you need to let's say you need to know which pod is actually behind this service. You will eventually find a pod IP, the endpoint, and then go to the pod. So here it will have another DNet, and go to the part C here. It's actually then the traffic or the request will finally go to the part C here. Yeah, here is actually the core gateway feature. You know that the gateway, the first thing that if you, from the user perspective, how would we select a node as gateway? You can go to the user guide to take a look at the details. For example, here the gateway configuration. For any node, as long as it can reached by other nodes in other clusters, you can nominate it as node gateway node. So here, if you think then you know that the node one can access other nodes from other member clusters, then you can annotate this node, and with this annotation, then this one it will be our active gateway. So it's simple like this. And once it's notated, our controller will be responsible to create a gateway CRD. Here, if you nominate annotated node, then you will see that a gateway being created. You can get this CR directly after that. You can see that here is gateway IP and the internal IP. Usually they're the same, but actually you can have another way to, if you like, that for the traffic for outside world, you need another external IP. Then you can use another annotation, this annotation, to assign the IP to the node. Then our controller will know that and update corresponding flow. Then the traffic can goes to the right node by your setting. Yeah, I think, yeah, this is a core feature of gateway. And yeah, okay, I think that's for the overview of our feature and the gateway. I'd like to hand over to Jiajing, or maybe I pause here for any question, or Cynthia, you have any question here?
Yeah, before we go ahead to the demo, let's do a quick recap here. So I
Hmm.
remember in one of our previous episode that we introduced the multi-cluster service, right? And I remember there is a, like you mentioned, there was a restriction that the multi-cluster service feature assumed that all the pods have the access to the other pods, right? So for example, here, the pod A in cluster A should have the access to the pod C in cluster C, right? So that's the
Yeah,
assumption. But
yeah, that's
now,
right.
yeah, but now we are like um create this gateway CRDs and like set up the node and the terminal to make it happen no matter if pod I can have access to pod C. So even if the
Yes.
like both of
Mhm.
these two nodes cannot talk to each other, but with the help of the gateway node, we can just like set use the SNet and DNet and leverage
Mhm.
the
Yeah.
bridge to leverage terminal to like that let them talk to each other.
Yeah, that's right. You know that with the earlier release, we do have some network requirements, which we need the underlying network to provide the pod access, so we can have this mat class feature. But for now, we have those gateway, and with those tunnel, and we can reach each other. Yeah.
Yeah, and the multi clusters. So if I am a user and I create a multi cluster service in cluster A,
Hmm.
uh, I I remember that there should be like a annotation or like some special label on the server to on the service to tell the Andrea controller that this is the multi cluster service, right?
Oh, I think that part I didn't give in detail introduce, but yeah, it's not annotation, but an export. You know, here we have detailed description. If you, for example, here we have
Oh,
CRD likes named service export. This one, the name is a service name, and this one is a service namespace. It will tell the controller, hey, I like to export this, or I like to share this Nginx to other member cluster. Yeah.
Yes, right. So
Mhm.
like if I if I create a service in cluster A, and I know it will be a multi-cluster service, but
Mhm.
like how
Yeah,
do I set
if you
up?
know that,
Mhm.
that's right. For example, here, you run an Nginx for a long time, and you
Uh-huh.
don't have other user from outside world. But for now, you know that, or you like to share this Nginx service to other member clusters in a cluster, then you have to create this CR first to tell the multi-class controller that, hey, this one is the service, or I like to share, or I like to export, then our multi-class controller will export necessary service information to the leader. Then the leader, other member cluster will watch this kind of information, right? Then import the service. For example, if you see a little bit, scroll down a little bit. For example, here, once you export this entry service in another member cluster, it will a new service import being created. This one named entry MC Nginx. So if you like to, let's say, if you like to access a shared Nginx, you have to access this service with this prefix, right?
Yeah, but my question here is that if it is a multi-cluster service, if I create a NGX service in cluster A, and
Mhm.
the endpoint is pod B and pod C, which is in cluster B and cluster C. So when I create this NGX service, will the corresponding endpoint be created because pod B and pod C are not visible to the to pod A to the cluster A, right?
Yeah, that's right. So, you mean the import service, right?
I mean, if I
Endpoint.
create a normal, so the first, if I want to create a multi-cluster service, the first step is to create a normal Kubernetes service.
Yeah, that's
And the
right.
next step is to create a service export. And then the
Yeah,
entry controller will take care of the rest of things. So when
yeah,
I
that's
create
right.
the, yeah, when I create the first normal Kubernetes service, what the endpoint of this service will be, or there will be like no endpoint created with it.
If you create a normal one, then just
Yeah.
like local service, no difference. Which means you will have you will be responsible to create the deployment, and you will have an endpoint with pod IP. They are all the same, no difference. The only difference that we will have a new and service named this with prefix entry MC dash MC Nginx. This is we would say that's multi-class service. When you create an Nginx service, it's just a regular service.
But the work like the traffic will hit pod B and pod C to support the traffic of this normal NGX service, right? If
Yeah, it's I say even your Nginx service have been exported by the service export, you can still access the Nginx service like the local service, right? But
yep,
if
but
you want to access the shared or multi-class Nginx service, you have to access this one. If you see this entry MC Nginx, this one is service import. But if you see the service in the following, sorry, it's not here. Maybe the I think Jiajing will demo. Then maybe it can show a little bit more clear. Once we have export Nginx service, all the member cluster will have a new service created. It's named entry MC Nginx. This service will have endpoint with the cluster IP endpoint instead of pod IP, right?
yeah. So I guess if I don't have any pod in cluster A which can support the traffic of NGX, when I like the first step I create a normal NGX service, the endpoint will be empty, right? And after I create
Mhm.
this service export, the uh, the cluster IP of the multi-cluster service will be the endpoint of my of my NGX service.
Yeah, actually, in our scenario, if you don't have a real pod in the back end, then actually, even you trying to export this service, it will be an error or warning information because there is actually no pod. Then it's no sense to forward this forward the multicast service to the local one, right? If there's no endpoint,
Mm,
right?
if there's no endpoint in cluster A, but the endpoint exists in cluster B, so, for example, in this graph, if
Mm-hmm.
I create a inject service in cluster A, but the endpoint of this service is pod B and pod C.
Yeah, yeah, that's right. I mean that, for example, all three clusters export the Nginx service, right? And all three clusters will have a new service named antrea Nginx. And after all this multi-class service created, the multi-class service will have endpoints including the cluster IP of each cluster.
Yeah, yeah, that makes sense. And oh, I see we have some audience here. So say hi to say hi to Jay
Hi,
and
hello.
and Michael. Jay and Michael are the Jay is the host of the Entry Live, and Michael is the friend of our show. So
Hmm.
like glad to see you guys here. And for other audience, if you like to log into your YouTube account, you can say hi to us in the comment. And also, if you have any questions, we can see that in the we can answer your question in the during the live time.
Hmm. Yeah.
Okay. So are we like gonna move to the demo part?
Yeah, yeah, okay. Let me stop sharing.
Okay.
Hello, hello everyone. Let me show my screen.
Okay.
Um, okay. Can you see my can you see my screen?
Yeah, we can see your screen.
Yes. Hu Jiajing. I'm working on VMware and working on Untrail. Today I will introduce some new feature of the Untrail 1.9 and make some demos about it. First of all, I want to review the review how to set up Ultramatic cluster. Um, let's see the user guide. First of all, we need to deploy the Ultramatic cluster controller on each cluster, including the lead cluster and the member cluster. And then we need to create the class set. Um, uh, um, a cluster including the lead cluster and the member cluster part. First of all, we need to apply the YAML files on the lead cluster and file. We will create a service account, secret, and role binding, and then we need to get the secret. Um, the secret is access token for the member cluster to access to the lead cluster. We can create one token for one class member cluster and one token for all clusters. That's okay. And there are so many. We just need a secret, and then we need to apply the secret on each member cluster to access to the lead cluster. And then after we did this, we need to initialize the class set. This part is both need to do on lead cluster or member cluster too. There are here is the YAML file. We will create one class two class on each member clusters and the lead cluster. After we did this, the control map cluster is working. It's done. When was a newer to Kubernetes and Antra, I found it not easy to deal with YAML file. Um, uh, especially the completed YAML file, I feel it's not it's not easy to deal with, and when I edit the YAML file, it's easy to um, it's not very easy. So in the Antrea 1.net, we will support the easy way to set up an Antrea cluster that is using our Antrea command line tool Antcato. Mm,
And sorry, maybe you
and
covered this in the previous episode, but I'm a little bit forget about this part. So I can see here we have two cluster claim and one cluster set, right? So if I
yes,
apply this two cluster claim and one cluster set to, let's say, cluster north, the cluster name cluster north, and then what I will get, I will join this cluster north cluster to the
no,
existing lead cluster.
we don't join. We don't use join. We just apply a file on the member cluster, just like this. There are two class claim and one class set two. The
Yeah, I think for the class claim, if you see the kind is class claim, the point of class claim is to provide or tell the whole cluster that what's the ID of this cluster. Even you are leader or you are member cluster, you need an ID to identify yourself, right? So actually, the first class claim, it's actually the ID. If you see the value, is the ID of
Mhm.
the cluster. And the second cluster claim, it's actually the class set identity. This is actually the ID of the class set. And then the third class set, it's including the necessary class set information. And for example, you see the leader's cluster ID and the secret which you like to use to access the leader, right? And the server is the host of the leader cluster.
Oh,
The key,
so
yeah.
mhm.
Mhm.
So the leader, so in this configuration, the leader cluster is cluster north, and one member cluster is cluster east.
Yeah, that's right.
Okay.
If there are too many member clusters, so we have to apply the YAML file once again and again. But the YAML it may be not easy. So if there is any easier way to set up a traumatic cluster, yes, and then we will provide a new command that is cluster MC init and cluster MC join command to make it easier to set up the untraumatic cluster. Mm, this is uh, this is a guide. Inclu- uh, Setting up the untraumatic cluster by at Kato, we just need two commands. One command is untra MC init, and another is untra MC join. Init is for the leader cluster to to create the resources we needed. We need to just like secret and row banding and service account and class clan and class cluster set. We can use some flags to name the resources, just like this class set. This is a test class set, and the class ID, this is a class ID leader, and we can and then we can also output the configuration. After we init the cluster in the lead cluster, there will be a configuration file, and we can distribute the configuration file to the member clusters, and the member cluster can use add cut MC join command to join the to join the class set. So we don't need to add too many YAML files, just like secret class clan clan set and other. We just need one that is join configure. Mm, just like kubeadmin, the class the article MC init and the article MC join is two. There are two steps to set up the multiple clusters. Make it easier to set up a multiple cluster set. So I will show how to use these commands.
And
Let's do how go
yeah,
ahead.
so before we do that, so the config file called join-config.yaml is the output of the encato-mc init, right?
Yes,
And this is like
the config
a
file
is that generated
is
by the
just like
MC
a
init?
yes, it's just like the configuration initiated by the lead cluster, just like
Okay, so
the namespace and like, yes, go ahead.
so for all the member clusters, the old way to join the cluster set is to apply the YAML you just showed with two cluster claim and one cluster set. But the new way is to just use this config file to join the command to join the cluster set, which is only one command.
Yes. Sometimes the administrator of the multi cluster is just need to distribute the join config file to the member clusters. So the member cluster will just need to join rather than edit the YAML file and apply and
Yeah, it looks like an easier way to join a cluster. So do you have an example of this join-config.yaml file?
uh, I will do a simple demo and show how the join config file looks like.
Okay, awesome.
Okay, let's begin the demo.
Yeah, I think before the demo, I like to highlight that this fancy simplified command line is introduced from 1.8. So maybe if you like to use this, and you need at least 1.8.
Antrea 1.8
Yeah,
version.
that's right.
Okay.
Yes, let's begin. Okay. There are three clusters when we just name it cluster lead cluster, member east cluster, and north cluster. So the KL it means that I used the lead cluster and the KE it means that I use the east cluster. And K, KW is the west cluster. I have already installed the antrea and the antrea MS command, antrea MS controller, but there is no class set in the cluster, so I need to set up the cluster, the multiple cluster class set. First of all, we just need to add cattle MC init. Here is the init command. The cluster set, the name of class set is a test class set, and the cluster ID is the test cluster leader. I will create the cluster in the multiple cluster, and this flag it means that we need to create token. Create token is a secret. Um, if we want to create the token yourself, it's okay. It's okay too, and and okay, we need it's successful. Let's show the join configure. The join config looks like this. The member cluster will just need to add the class ID and the namespace. Sometimes if we want to use this is the secret for the token we created by the artcard MC init command. But if you want to use the token by the other token, we just need to set the token name here. Oh, we can also create the token from a secret file too. So as a member cluster, we just need to provide the cluster ID and the namespace, just like this. Yes, the West cluster, the join command for the West cluster is looks like this. We just need to set the cluster ID and the namespace, and this is the config file. Config file is the join config file is just we generated just now. So let's join now. Yes, it's successfully, and then we need to join on the East cluster. Yes, the same command, just we replace west with the east. Okay, it's successful too. Let's get the cluster in the lead cluster and check the status of the member clusters. We can see that the member cluster is connected now, and the tab is ready. So maybe the the cluster east and the member cluster east and the member cluster west is ready now. Let's check and create. Mm, let's check the service. I create I create two Nginx pod in the both lead cluster and the member cluster. Then I will create the um, um, I will create a service export to check can we access the remote service from another cluster.
Hello, Jiajing. Do we have a service? I didn't see you apply the service YAML.
Oh yeah, I will I will create the service now.
Oh, okay.
First of all, we need to annotate the node to create the gateway. Yes, and I will create a service named Nginx, and a service export. It means it's Nginx 2.
So I think actually in this service YAML, it's including the service and also service export,
Yes,
not only the service.
yes. Let's check the service now. You can see that there is a service named TriMC East Nginx in the West cluster. I used KW get service. So here is here is a remote service. Let's try to access. Um, yes, it works well. So the cluster on the antrea map cluster, it works well now. It works well. Let's review the steps. Oh, first of all, we just use the articato mc init command to init the cluster in the lead cluster, and then we used two join command, just like this. I used to two join command and set the cluster ID and the namespace, and just like this, and the member cluster will join the cluster in the lead cluster, and then the cluster works well. So I think it is an easy way to set up an trauma cluster to avoid the editing the too many YAML files and too many steps. I think it's a better way to set up the Antrea multi-cluster.
May I
And then
ask,
I will.
um,
Oh, go ahead, please.
may I ask how many nodes are there in West and East cluster?
Um, I used canned to create the cluster, so there are one must node and two workload. There are three node.
The three
Three node.
nodes. And
Yes.
which
Yeah,
node is the gateway node?
yeah, Jiajing, I think you can share
I
the
just
gateway. Show the
okay.
gateway.
Mm, the gateway is cluster west node, and this node is the gateway. Works as well the gateway, and as well as the east cluster. The cluster east works as a gateway too.
Okay, so in your setup, the cluster West Worker 2 cannot talk to the. I assume you have like a cluster East Worker 2, right? So in your
Yes.
setup, only the cluster West Worker can talk to the cluster East Worker.
Um. I no. No. The cluster work too and can connect with the cluster east work too. Uh, but the traffic will not through the cluster west work two and the cluster east work two. Because we
Mm.
the gateway is on the cluster west worker. Mm, this because I create the clusters by hand, so we all the nodes can connect with each other, but sometimes we do not use the canned. We just use machine on VM and maybe on AWS and other cloud machine. So the gateway will maybe the gateway will just can access to gateway.
Okay, so even though the node here can access each other no matter they are in different clusters, but the idea here is to show people that if you create a multi-cluster service and it can be the endpoint of the cluster of the service is the like the cluster IP of the other service in other clusters.
Yes.
Okay.
Mm, let's show the endpoint. Endpoint of the engine is service IP is the service IP of the East just like this cluster IP. This is the endpoint of the West cluster, and this is the cluster IP in the East cluster. It's the same.
Okay, yeah, that is the entry controller that update this part, right? So normally the
Yes.
endpoint is the pod that support the traffic, but now since it's a multi-cluster service, the endpoint is the cluster IP. Is the cluster IP of the service in other clusters.
Yes.
Okay, that's cool.
Okay. Mm, in Control Window Night, sometimes we can access to the remote service by use service export, but sometimes we don't want to use you don't want to use the service export. We just access to the remote port directly. Let's see the architecture of the multi. Sometimes the traffic between the cluster is just like this. We will do a DNet on the node and the SNet on the gateway, and then DNet on the remote gateway, and so the traffic will access to the port, another port, the port A to port C. Sometimes um we want this traffic work is get access to the remote port by the Kubernetes service. Sometimes we don't want to use the service. Sometimes if I am the user of the cluster A, we just want to visit the cluster the port C directly on port A. How to solve this? The Antrea 1.net apply um, support another now support this now. We can just add some configurations on the Antrea MC configure, and then we can just visit the policy on port A directly, and do not use the Kubernetes service. Um, to enable this feature, we just need to export the port headers of the clusters. Just once we run the Kubernetes Entra multiple cluster, there are some configurations, and let me show it. Sorry, there are some configurations the Entra MC controller configure is the configuration of the multiple cluster. We just need to add the port header in this part, and then we can access to remote port directly rather than using the Kubernetes service. Then I will show you how to use this. First of all, we need to add the service to add the configure to enable this feature. The port header now is empty now. It means that we do not support port directly. And if we want to enable this feature, we just need to replace the empty fields with our cluster port header. In the lead cluster is the one is like this. Looks like this, and then we just need to restart all the Entra pod. We need to do the same way, do the same thing on the west cluster. Yes, and port side is a port side of the cluster. Sometimes you can use another port side just maybe we can just use only the port IP of port IP, but I think the port side of the cluster is more reasonable.
So if I understand this correctly, what you're trying to say here is that if I set up this port cider, for example, 10.12.1.1, and the IP in this range can be accessed by any pod in any cluster.
Yeah, here is the port side we want to export. So sometimes the IP address of the port will change. So maybe we cannot to control the how the new IP address of the new pod once a pod restart. So the just use the port side of the cluster is reasonable. Sorry.
And we set up this configuration in the antrea multi-cluster controller. So
yeah,
are you saying that if I create a pod, the IP of this pod comes from the antrea multi-cluster controller?
this port this you mean this port side is controlled by the multi-cluster controller, or
Actually, this cider Jiajing, I think, is trying to say that it's recommended to use the same pot cider which you have in your local cluster.
Oh, okay.
Yeah. So if you
okay,
trying to use maybe one IP in this one in this cider, then you may
Mhm.
just allow one IP. But the policy IP is changed frequently, so it would be better to use a cider instead of maybe just one IP with slash 32 the cider. It means the one single IP, right? It
Yeah.
doesn't make it's actually not useful if only one IP here or a small cider. So usually it will be the same cider which you provided when you set up the cluster.
Okay, gotcha.
okay. Let's continue. Then we need to restart the port now. By the way, on the port side of the class of the configuration, if we want to enable the port-to-port connectivity feature, the port side of among the clusters cannot be overlapped. So okay, let's check. Let's restart now, and then let's check the port IP of the NGX. Okay. Okay. Let I now I can access to the port in on the cluster east. This port, this NGX. I get it on the cluster east, and I I can access to it directly in the port on the cluster west, just like this. I used kube control exec to get into the port and run the call command. Just call the IP address of the port on the class east, and it works well now. Um, just now, yeah, this one I call the remote service. It works well now, and I call the remote port IP. It works well now too, which means that I can just access to the remote port from local port directly rather than use the Kubernetes service. It works well, and maybe sometimes we need to get access to the remote port directly. We can enable this feature. That's my that's the new feature now. The demo one for Atcato MC command to set up on the Antrea multiple cluster easier, and another is for port-to-port connectivity, which means that we allow we are allowed to get access to the remote port directly, um, rather than do not use the Kubernetes service and the service export. That's my demo.
Okay, thanks, Judging, for this great demo. I think it's clear. It's very clear, like how we use this command to control these features, and also I would like to thank Lan for the great introduction of what is a multi-cluster gateway and what's the relationship between the multi-cluster gateway and the multi-cluster service. I learned a lot from this episode. So let's see if there's any questions from our audience. Okay, it looks like um it looks like everyone understands easily, and we don't have any questions here. So is there anything else you want to mention before we end this show?
Yeah, I think one thing I like to highlight is that we allow the pod direct connection. Since pod IPs change a lot and is very frequently, maybe you might wonder why we like to use the pod IP direct access. There are actually some scenario, maybe in the big data scenario, that the user like to use maybe the pod will have fixed IP, which means that, for example, the pod provide the data access and these are stable, and there are some customized scenario, and the pod IP is fixed. So in this kind of scenario, the user like to use this kind of pod direct access, and it will help them to do those development as well. Yeah,
Yeah.
yeah,
It's a customer requirement, right?
yeah. That's right.
Okay, thanks, Lan, for this information. And I think we're run out of time. So thanks everyone for joining us today. Hope you have a great night. Thank you. Bye.
Thank you. Bye.